Okay, so nuclear decay is the breakdown of a nucleus. And so there are some main nuclear decays that we want to talk about and make sure we have a good understanding about. So the first one we're going to look at is alpha decay. Okay, and alpha decay is the weird little fish thing. I'm not very good at drawing it, but that's kind of what it looks like. Okay, alpha decay is the release of it from a nucleus of a helium nuclei. So what we mean by that is it is 2 protons and 2 neutrons, which would be the same as a nucleus of helium. Not a helium atom, so it doesn't have the electrons and everything. It's just the nucleus of helium particle. So if we think about, if we've got this substance here, okay, and these are all the protons and neutrons in there, so I'm going to make some of them red. Okay, so let's say that red's my protons and the black is my neutrons. Okay, this substance is going to break down. So it's an unstable nuclei and it's going to break down. If it breaks down by alpha decay, what you would get, okay, is a little particle that contains 2 neutrons and 2 protons. And that's your alpha particle right here, okay? The other part left over of this, so I'm going to go down here. So we had 1, 2, 3, 4, 5, 6, 7 of those. I got rid of 2 of them, so I've got 1, 2, 3, 4, 5 left. Okay, 1, 2, 3, 4, 5, and I'm down to 3 of these. So this is an example of an alpha decay where you see that the substance breaks down into 2 new substances and they're more stable than what they were before. So this is what it looks like at a particle level. Let me now show you what it's going to look like at a written level. So americium-241 is used in smoke alarms, and it's one of the things that you could research for your nuclear flip grid. And so americium-241 is known to go through alpha decay. So when we look at a written nuclear decay problem or a nuclear reaction, we see what's called the parent, okay, isotope, which is what we're starting with. So if I come down here, I've got my americium as my parent, and I tell you it goes through alpha decay. Well, alpha decay is the release of a helium nuclei. That means that the daughter substance would be 237 neptunium. So let's take a look for a moment and see how we get this new daughter isotope. So we had 241 right here, and we know it went through an alpha decay. So there's the mass of 4 that it lost. So 241 minus 4 is 237. That means that leftover chunk has to have a mass of 237. We had 95 protons. 2 are that helium particle that busted off, so then 93 is left over. I look at my periodic table and I notice that neptunium is number 93. That's how I know who my daughter isotope is. Let's go ahead and try one more, and you can pause the video to see how you do with this. So another substance that maybe goes through an alpha decay is going to be uranium-238. And uranium's number is 92. I'm telling you it goes through an alpha decay. Why don't you take a moment, pause the video, and see if you can predict the products. We're back, and hopefully you had a good experience with this. So your helium is your alpha particle. You're going to end up with 234. You're going to go down to 90 on your periodic table. Number 90 is thorium. This is your new daughter isotope. It was an alpha decay. So these are the alpha decays. It's what they look like written out. These are the weakest of the nuclear decay, and it can be blocked by a piece of paper. So think piece of paper in the background here. There's a reason I use this one. All right, that's your alpha decay. Look for your next video for your beta decays.